All right, so page 387, example number 7. In this example, you'll notice that our three fractions have three different denominators. It's almost like having three different numbers. So if you had in numbers, if you had something like this, between 5, 7, and 3, there's nothing in common. So your lowest common denominator would be just 5 times 3 times 7. So same thing would happen here. It would be just x plus 2 times x plus 1 times x, which means my non-permissible values cannot be equal to -2, -1, or 0. So we get those from these three. So let's take a look at the first one. The first fraction already has x plus 2. So that means in order to become this lowest common denominator, it needs to be multiplied by x plus 1 and an x. So 3 times, I just like to write monomials first, times x plus 1. You don't need to write it over here. You could just jump right over here. So -2, and this one is x plus 1, so it will be multiplied with the x and x plus 2. And then the last one only has an x, so this one will be multiplied by x plus 2 and x plus 1. So whatever is missing is what you're multiplying it with. Okay. Now you're going to open up your brackets where you can easily, and then if not, then pull it to the side and do it. So this one is just 3x. So 3x times x is 3x squared times 3x. This one is again -2x. -2x times x is -2x squared. And then this will give you -4x. This is now a binomial with binomial. So it might be okay to actually take this on the side to first work it out. And then this will end up becoming x squared plus 1x plus 2x plus 2, so x squared plus 3x plus 2. So when I bring this over here, multiplied by 1, doesn't really change anything, so it just stays as x squared plus 3x plus 2. If there was a negative here, I would have brought back the answer with the bracket around and then distributed that negative in, or as I'm writing down, making sure that I change my bracket if you feel comfortable doing that. The denominator will have my three factors. I'm just going to bring them back once I simplify the numerators. So we're going to combine our like terms. So I have 3x squared minus 2x squared and then plus x squared. So I have these x terms that I'm going to combine. And that's 1. 1 plus 1 is 2. Then I have 3x minus 4x plus 3x. 6 minus 4 is 2, so that gives me plus 2x, and then that leaves me with just this whole number plus 2. Now I'm going to write down my factors. So my factors are x, x plus 1, x plus 2. You can write them in the order you have, or if you want to just organize them because you feel a little crazy, go ahead. Now, I would be done, except I want to make sure that my top cannot be factorized any further. So I'm going to start trying to factorize it. So I can take a 2 out. And then I'm going to see if I can factorize x squared plus x plus 1. If I can factorize it into two binomials. There's nothing that will multiply to become 1, but also add to become 1. So no, can't do it. So this is my final answer. So unfortunately, I could not factorize it, and then nothing could get canceled. So my final answer is this, along with the restrictions. So what do I mean? For example, if you had a question where you could factorize the top. So let's say the top, it was instead of x squared plus x plus 1, what if there was a 2x in here? So something that looked like this. So this is just a made-up example. Okay. So in that type of question, you would have had x plus 1 times x plus 1. You'll notice now it becomes like a reducing question where you could reduce potentially. But we don't have that, so that's why this is our answer. So practice the rest of this lesson, and we're going to do part 2 next class.